Hey guys, welcome to CPM 2. This is Module 2, Lesson 2, and we are multiplying and dividing fractions. And so, multiplying and dividing is actually a lot easier than adding and subtracting fractions, so that's why we're starting here with multiplying and dividing. So, right here tells you how to multiply and divide your fractions. It says to multiply two fractions, you're simply going to multiply the numerator and multiply the denominator. So we are multiplying straight across. So on example 1, we're going to multiply the numerator. So 2 times 5 is 10. Multiply the denominators. 3 times 11 is 33. On B, same thing. Kind of look at this as a whole first though. You've got a positive times a negative. So when I do multiply, this is going to be negative. So now almost don't even pay attention to this negative anymore. We've already dealt with it. So now 1 times 1 is 1 over 4 times 8 is going to give me 32. So we get negative 1 over 32. Now you can kind of do this negative where it's neutral, the way I've wrote it. This would be the same as negative 1 over 32, and this would be the same as 1 over negative 32. It doesn't matter where this negative goes as long as you have one of them. So it can be neutral, it can be in the numerator or in the denominator. Just make sure it's only once that you got the negative, not negative 1 over negative 32. Now, these first two, that's kind of all we had to do with it. When you have fractions, you want to make sure it doesn't simplify at all. But like 10 and 33, there's nothing you can divide into both of those. 1 and 32, there's nothing you can divide into those. And in fact, anytime you have 1, it's simplified. But on these, now we're going to have to simplify our fractions after we multiply. And so from here on out, anytime you have a fraction, before you box it, circle it, whatever, you've got to make sure it doesn't reduce. So on A, we've got negative times positive. So I do know this is going to be negative. And now multiply straight across. We got 6 times 14. So 4 times 6 is 24. Carry your 2. 1 times 6 is 6. Plus 2 is 8. Multiply on the bottom here. We've got 27 times 7. 7 times 7 is 49. 2 times 7 is 14. Plus the 4 is 189. Okay, so let's check to see if it can reduce. Now, hopefully they're not going to be as big as these numbers, but still check. So I know I can't divide a 2 in because 9 is not even, so let's try dividing into a 3. So we've got 3 into 84. 3 goes into 8 2 times. That gives me 6. Subtract to get 2. Bring down your 4. 3 goes into 24. 8 times. So this is negative 28 over. So now do the same thing with your 89 and 3. So we've got 3 into 189. 3 can't go into 1, but 3 does go into 18 6 times. 6 times 3 is 18. Even though you get 0 here, you're not done until you brought all these numbers down. So we got 9. So 3 goes into 9 3 times. So we get 63. These are still not done because now that I have numbers that I know more multiples of, we can divide both of these by 7. So divide by 7, divide by 7, negative. So then we have 28 divided by 7 is 4. 63 divided by 7 is 9. So, can I divide anything into 4 and into 9? No, you cannot. So this is your final answer. Now, as you can see, this took a lot of work, right? We had to multiply numbers out, then we had to divide to reduce them. You get big numbers when you do it this way. I don't think I'm even going to do B because B's got even bigger numbers. I want to bring you down to example 2A again. So notice I have the same problem. And it says on this one to try cross-reducing before you multiply. This allows for smaller numbers. And that's good. So when you cross-reduce, because it's cross-reduce, you're looking diagonally. You're wanting to see, is there anything I can divide into both 7 and 14? Well, yes, we can divide 7 in. So 7 divided by 7 is 1. So I'm going to cancel out that 7 and put in a 1 there instead. Whatever you divide this bottom one by, you've got to divide the top one by 2. So 14 divided by 7 is 2. So I'm going to cross out 14 and make it a 2. Do the same thing going this diagonal. Is there anything you can divide into 6 and 27? That would be 3. So 6 divided by 3 is 2. So cross that out, make that a 2. 27 divided by 3 is 9. So cross it out, make it into a 9. So now multiply straight across. So now this looks like negative 2 over 1 times 2 over 9. So now when I multiply straight across, negative times positive is negative. 2 times 2 is 4. 9 times 1 is 9. Would you rather do this amount of work or this amount of work? Hopefully you said this one because this one's got a lot easier. It's a lot less work. So I'm not even going to do B here. Let's just figure out what the answer is to B on this one. That way we don't have to multiply, multiply, divide, and divide. So, cross-reduce. So, look diagonally. Is there anything I can divide into 7 and 77? Weirdly enough, it's 7 again. Not always going to happen, FYI. So, 7 divided by 7 is 1. So, I'm going to cancel this out, make it a 1. 77 divided by 7 is 11. So, cross it out, make it an 11. Now, look this way. Is there anything I can divide into 6 and 8? So that's 2, since they're both even. So cross out these numbers. 6 divided by 2 is 3. 8 divided by 2 is 4. So now I have 3 over 11 times 1/4. So multiply straight across. 3 times 1 is 3. 4 times 11 is 44. Can you divide 3 and 44 by something? Well, no, 3 is a prime number. If you got a prime number, you can't reduce. Okay. Now, if you do all of your cross-reducing correctly, you should never have to reduce your final thing. Okay, so if you take care of business here, this business is good. Same thing happens when you have multiple numbers. I'm still going to cross reduce. I really don't want to do 4 times 1 times 33. That one actually wouldn't be so bad. But I don't want to do 11 times 5 times 16 and reduce it. So, cross reduce. Now, you can do this 4 with either of these bottom ones. You can do this 1 with either of the diagonal ones, or you can do this 33 with either of these here. So kind of look, 1 in the top, 1 in the bottom. Is there anything I can reduce? Well, I do know 4 and 16 are both divisible by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So look at anything else. I know I can't reduce this 1 with anything because it's 1. But 33 and 11 I can deal with. So those are both divisible by 11. So 33 divided by 11 is 3. 11 divided by 11 is 1. So now multiply. We've got 1 over 1, which we really don't need, but 1 over 1 times 1 over 5 times 3 over 4. Now I don't multiply. I don't mind multiplying straight across. So 1 times 3 is 3. 1 times 5 times 4 is 20. Can I divide anything into 3 and 20? Well, again, no. 3 is a prime number, so we are done. Okay, now even though this one has a variable, it's still the same thing, so don't let that trip you up. Don't let that trip you up. So go diagonally. 2 and 8 can be divisible or can be divided by 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. This way here, 6 and 3y, those are both divisible by 3. So 6 divided by 3 is 2. 3y divided by 3 is just 1y. Right? You've got 3y divided by 3. Your 3's cancel. You're just left with y. So we have 1/2 times y over 4. And actually this is a negative. So don't lose that negative in your process. So now negative times positive is negative. Multiply straight across. 1 times y is 1y. Or just y. 2 times 4 is 8. Can you reduce? No, we cannot. Now in E, it's the same thing really as D. But we just don't have a fraction yet. It makes it easier if you have a fraction. If you don't need a fraction, then you don't have to use one. But to make this into a fraction, this is the same as negative 10x squared all over 1. Okay? So, can you cross reduce? You've got 1 and 2. Anytime you have 1, that's not divisible. Look this way. You've got negative 10 and 3. Well, 3 is a prime number, so you can't divide. So on this one, just multiply straight across. We do have negative times negative, so my answer will be positive. So you got 10x squared times 2. So that gives me 20x squared. Sorry. And then on the bottom, you got 3 times 1. So that's 3. And again, this one's positive because you got negative times negative. And then F is the easiest one yet. 0 times anything is 0. Whether it's a fraction, decimal, or whatever the case may be. On objective B, it says evaluate exponential expressions with a fractional base. So remember, this just tells me, this exponent tells me how many of these bases we have. I got 3 of them. So in this one, we expand it. You've got 2 over 5 times 2 over 5 times 2 over 5. So whatever the base is, you have that of however many exponents, whatever that exponent is. So look if you can cross reduce. You've got 2 and 5 2 and 5, 2 and 5, 2 and 5. You can't reduce anyway, so just multiply straight across. 2 times 2 is 4, times 2 is 8. 5 times 5 is 25, times 5 is 125. Now, B, remember when you have this in parentheses, your negative is included. So I have negative 1/4 5 different times. So we've got negative 1/4 times negative 1/4 times negative 1/4 times negative 1/4 times negative 1/4. Instead of doing this one all together, because this one's got a little bit easier numbers, 5 of these 4s is not quite as easy. So I'm going to do this one a little bit different than I did that last one. I'm going to multiply these two together. So negative 1/4 times negative 1/4. Negative times negative is positive. 1 times 1 is 1. 4 times 4 is 16. I'm going to multiply these two together. So again, it's the same thing, right? Negative times negative is positive. 1 times 1 is 1. 4 times 4 is 16. And then I don't have anything to multiply this one by, so I'm just going to bring it down. So keep multiplying straight across. So now this one, we've got 1 times 1, which is 1. And now 16 times 16. So 16 times 16. 6 times 6 is 36. 6 times 1 is 6, plus the 3 is 9. Skip a spot. So 1 times 6 is 6. I've already used that 3. 1 times 1 is 1. So we get 6, 15, carry your 1, 256. Times a negative 1/4. So now positive times negative is negative. 1 times 1 is 1. And now I need to do 256 times 4. So this is 24. This is 20 plus 2 is 22. And then 2 times 4 is 8. Plus the 2 is 10. All right, so not the easiest one, but pause that video, rewind it as you need to. So now we're going to move on to divide. Divide says before we can divide fractions, we need to know how to find the reciprocal of a fraction. So it says two numbers are reciprocals of each other if their product is 1. The reciprocal of a fraction is this right here. Notice you had A over B and now it's B over A. When we say reciprocal, this means flip your fraction. Okay, so for example here, 2 over 5, the reciprocal is simply 5 over 2. You're just doing the opposite of it. It was 2 over 5, now it's 5 over 2. Okay, the reciprocal of negative 11 over 7, keep the negative with it, but then flip your fraction. So instead of it being 11 over 7, now it is 7 over 11. Okay, but notice negative and negative, keep the sign. C, flip your fraction. So instead of it being 1 over 5, now it is 5 over 1, which 5 over 1 is the same as just 5, right? So use that information to help you on 10. 10, you don't have a fraction. So how do you make negative 10 into a fraction? Negative 10 over 1. So now when I flip it, instead of it being negative 10 over 1, now it is 1 over negative 10. Okay, and remember that negative, it doesn't matter where it goes. So I'm choosing it to go in the bottom. It can go in the top. It can be neutral. Okay, it can be more neutral like this one is here. So when you find the reciprocal, all you are doing is flipping the fraction. This is going to help us on the next page when we are dividing. So now, when I divide, it says multiply the first fraction by the reciprocal of the second fraction. So, we are, let me move this up some. We are keeping the first fraction. We will then change this division to multiplication. And then you can either say, reciprocal of the second one, but I think it might be easier just to say flip the second fraction. Okay, which is the reciprocal. Okay, so let's try it on this one here. You're keeping the first fraction, so this negative 5 over 16 comes down. Changing division to multiplication, and then we are flipping this fraction. So instead of it being 3 over 4, now it is 4 over 3. So see if we can cross reduce. So look diagonally. Can you divide anything into 5 and 3? No, those are both prime numbers. Can we divide anything into 16 and 4? Yes, that would be 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So I have negative 5 over 4 times 1/3. So multiply straight across. Well, first off, we've got negative times positive. So that does mean this is negative. But then multiply straight across. 5 times 1 is 5. And 4 times 3 is 12. Okay, B, let's try again, and it's the same thing. Keep this first one. So we got negative 2 over 5. Change your division to multiplication. And then this 1/2 becomes 2 over 1. So, see if you can cross reduce. You got 2 and 1, those are both prime numbers, so no. 2 and 5, those are both prime numbers, so no. So negative times positive is negative, and then multiply. 4 on the top, 2 times 2. And then 1 times 5. And anytime these numbers are right next to each other, that's never going to be able to reduce. Now you do have a helpful hint right here, and this one's a pretty good helpful hint. It says, when dividing by a fraction, do not look for common factors to divide until you rewrite the fraction as you multiply. So if you notice here, if I cross reduce, we could reduce like this becomes 1, this becomes 1, but you do not cross reduce until after you write this as a multiplication. So it says, until you rewrite the division as multiplication, do you reduce. So just kind of keep that in mind. All right, number 6, perform the indicated operations. Now we got 2 operations. So we need to use our please excuse my dear Aunt Sally. All of these have to do with multiplication and division. So we are using this my dear portion. Remember with this, no. We are actually using this portion here. Remember, parentheses is always first. So in this problem, we've got multiplication in parentheses. So we're going to multiply first. And this one we have division first. So we're going to divide first. So on this portion here, look if you can cross-reduce. Can't cross-reduce 7 and 3. Those are both prime numbers. But this way with 4 and 8, we can divide both of those by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So I have 1 over 7 times 3 over 2. Multiply straight across, we get 1 times 3. And we get 2 times 7 to get 14. So then bring down your divide by negative 3 over 4. And now I need to rewrite this. So this is going to be rewrote as 1 over 14 times, flip this, so negative 4 over 3. So check if you can cross-reduce. This way here, we can cross-reduce by 2. So 14 divided by 2 is 7. 4 divided by 2 is 2. Can we cross-reduce this way? No, those are both prime numbers. So I don't really have room to rewrite this, but still multiply straight across. Positive times a negative is negative. We've got 1 times 2, and we have 7 times 3. And again, prime number, can't reduce that. Okay, let's try again. This time, we have to start with the division on this one. So, change this into a fraction first off. So this is negative 1 over 1. We're changing division to multiplication, and then we have to flip our second fraction. Cross-reduce if you can. 1 and 5 are both prime. 1 and 2 are both prime. So multiply straight across. We got negative 1 times 2 and 1 times 5. So then bring everything else down. We got times negative 2 over 3. Cross-reduce if you can. We got 5 and 2. That doesn't reduce. And 2 and 3. That doesn't reduce. So multiply straight across. Negative 2 times negative 2 is a positive 4. 5 times 3 is 15. Again, you want to look at it. Can you reduce 4 and 15? But if you can't cross-reduce here, then you can't reduce this fraction. So that's our final answer. All right, and last page. It says, if x equals this and y equals this, evaluate the following expressions. Well, what's going on between this x and this y? They're being multiplied, so we're going to multiply. So x is 7 over 8, so we got 7 over 8 times my y is negative 1/3. So cross-reduce if you can. 1 and 8, 1 is positive, or is prime, you can't. 7 times 3, 3 is prime, so we can't, so just multiply straight across. Positive times negative is negative. 7 times 1 and 8 times 3. And again, if you couldn't cross-reduce, then we can't reduce this fraction, plus 7's a prime number. Now I'm going to take those same numbers, but now divide. So now we have 7 over 8 divided by negative 1/3. So keep your first one. We've got 7 over 8 change division to multiplication, and then flip the second fraction. So instead of it being negative 1 over 3, now it's negative 3 over 1. So cross reduce if you can. 8 and 3, 3 is prime. 7 and 1, 7 is prime, so multiply straight across. Positive times negative is negative. 7 times 3 is 21. 8 times 1 is 8. And again, if you can't cross reduce, then we can't reduce at the end. All right, we're going to end this with a couple word problems. So E, we are solving applications that require multiplication of fractions. On 8, it says find 1/5 of 60. Tells you here of usually translate to multiplication. So if of means multiply, we're just multiplying these two things. So I've got 1/5 times 60. If you need to, make 60 into a fraction, so that's 60 over 1. You don't have to if you don't need to. Cross reduce, we've got 1 and 1. Definitely can't reduce there. Reduce here. Can I reduce? Yes, I can. 5 divided by 5 is 1. 60 divided by 5, well, let's figure out what that is. 5 goes into 60 one time. That gives me 5. Subtract. Bring down your 0. 5 goes into 10 twice. So this will reduce to a 12. So now 1 times 12 is 12. 1 times 1 is 1. Now this is the correct answer. It's a little bit better if we make that as a 12. Simplify it as much as possible. But those are both correct and both acceptable. And then last one, Cedar Point is an amusement park located in Sandusky, Ohio. Its collection of 72 riders is the largest of the world. Of the riders, 2 over 9 are roller coasters. I said riders, but that was rides. Sorry, I was wondering why this didn't make sense. Its collection of 72 rides is the largest in the world. Of the rides, 2 out of 9 are roller coasters. How many roller coasters are in the collection? So multiply. We have a total of 72. And so my portion of the rides is 2 over 9. So multiply and solve. So on this one we cross reduced. On this one, let's just multiply straight across. So you can change your 72 to over 1. So I've got 2 times 72, which is 144. 1 times 9 is 9. So divide. How many times does 9 go into 144? 9 goes into 14 one time, which gives me 9. Subtract to get 5. Bring down your 4. 9 goes into 54 6 times. And so my final answer here is 16. So remember, word problems require word answers. It wants to know how many roller coasters in the collection of the rides. We have, we'll go ahead and put Cedar Point has 16. If I could spell, that'd be awesome. Roller coasters. All right, that's all I got for this lesson. Rewind this video as you need to. Let me know if you have any questions.